All right, so each of these exercises here is pretty similar to one of the exercises that was on page 2 of these notes, um, or one of the examples here. So if you're not sure where to get started with these, uh, I would go back to the previous video and find an example there that's similar to this to try to understand that explanation, to get your equations set up in a way that makes sense to you. Um, so let's try that. Do as much of these as you can. I'm going to go through the answers in a moment. It's going to be a lot faster than it was in the example video from the other one because these are exercises and you're just checking your answers, hopefully, or maybe just getting unstuck. So anyways, here is your chance to pause it and do these if you haven't yet. Okay, so let's see. For exercise 3, we want to write this in this form, the doubling time or half-life time, and also in this form to find the growth rate. So if it starts at 200 bacteria and doubles every 3 days, so that means the growth factor is 2, and it has that growth factor every time t increases by 3. So it should be 2 to the power t over 3. Then to get that into this form, we're going to write this as 200 times 2 to the power 1/3 to the power t, and 2 to the power 1/3 is 1.26. And that's the same thing as 200 times 1 plus 0.26 to the power t. So yeah, we can see that the growth rate every day is 26%. Okay, so I guess the question was asking for that and also asking for the daily growth rate. So we have a radioactive material that is decaying. Every 5,000 years, it gets cut in about half. I think that's approximately the half-life of carbon-14, the stuff they use for radioactive carbon dating. So let's see. So going from 500 milligrams to 25 milligrams is getting cut in half. So the formula is going to become, starting at 50, it gets multiplied by 1/2 when the exponent goes up by 5,000. So that's that formula of it, that form of it, the A times B to the power T over big T. Now to get the yearly decay rate, we're going to write this as 50 times 1/2 to the power 1 over 5,000, and then that to the power t. This is going to give us 0.99986. Which is the same thing as this e to the -4 means times 10 to the -4, so we need to move the decimal place over 4 spots. It's going to become negative 0.000139. So that is the yearly decay rate. We probably want to write this as a percentage. To write it as a percentage, I'm just going to move that decimal place over 2 spots. It will become 0.0139%. Okay, a quantity grows by 0.5% per hour. By what percent does it grow in 1 day? So let's see. Let's say that t is the number of hours, I guess. And if it's growing by 5% per hour, this is going to be Q equals A, the starting amount, whatever that is, times 1 plus 0.005 to the power t. So I move this decimal place over 2 times to get that 0.005. By what percent does it grow in 1 day? Well, let's see what we get when t is 24. So here t is the number of hours. So when t is 24, that's 1 day later. And that's going to be 1.127. Which is the same thing as whatever the starting amount is times 1 plus 0.127. So you have 100% of what you started with, that's the 1, plus 12.7%. So that is the daily growth rate is 12.7%. All right, so for exercise 5, a quantity decreases by 8% per month. So by what percentage does it decrease in 1 year? Let's see. So if it's decreasing by 8%, we can say the quantity starts at A, whatever that is, and we're going to do this as 1 plus negative 0.08 to the power t, where t is the number of months. I could call this m, maybe. That might make more sense. And 1 minus 0.08 is 0.92. So this is saying every time 1 month goes by, you have 92% of what you had before. By what percent does it decrease in 1 year? That's going to be when m is 12. So and 0.92 to the power 12 is 0.368. So what percent did it decrease? We want to think of that percent decrease as if you had this as A times 1 plus something. What is that number going to be? That's going to be 1 plus what is 0.368? I think I can do this in my head. I think it's going to be negative 0.732. Let me check that. Oh, no, it's supposed to be 0.6. I got 6 mixed up with 7 there. Okay, so it's decreasing by 63.2%. is how much it decreases in 12 months, or 1 year. All right, exercise 6. A quantity grows by 12% each day. By what percent does it grow each hour? So there's two ways to approach this. You might be saying your variable t represents the number of hours, or you might say it represents a number of days. They should give you the same answer to the question, though. I'm going to let's say h is the number of hours. So if h is the number of hours, then a formula for this is going to be q equals a, whatever the starting amount is, times, there's a mosquito on my computer. Hang on a moment. I tried to swat it, but I missed. Okay. Anyways, let's see. So it's growing by 12% each day. So the growth factor is going to be 1 plus 0.12 every day. So if our variable is the number of hours, then this is going to happen every time the number of hours goes up by 24. So I'm going to call this h over 24. All right, so and so yeah, this is going to be 1.12 to the power h over 24. You can write that as a times 1.12 to the power 1 over 24, and then that to the power h. So if you do 1.12 to the power 1/24, that will be the hourly growth factor. We get 1.0047. to the power h. So you could also write that, if we're trying to get the percent per hour, we want to have it in like this kind of form, with a times 1 plus something. And that something is going to be 0.0047 to the power h. So every hour is going up by this growth rate, which as a percentage is going to be 0.47%. So exercise 7, it decreases by 96% each year. By what percentage does it decrease each month? I'm going to do this with the same kind of approach as before. So it's going to be q equals a times 1 minus 0.96 to the power m over 12. So in other words, that's going to be a times 0.04 to the 1/12 power, and then that to the m. So if it's decaying by 96%, decreasing by 96%, that means you have 4% every time m goes up by 12. So that should be the formula for it. And you can write this in the form, we gotta find that number, 0.04 to the power 1/12. Which will be 0.765. to the power m. And if you want to write that, that's your monthly growth factor, is that. If you want to get what is the percent decrease each month, we're going to do 1 plus something to the power m. That's going to be negative 0.235, I think. Yep. Okay, so that's your monthly decrease, is 23.5%. For exercise 8, the population of the town was 1,500 people in 2014 and increasing at a rate of 2.5% per year. So what we want to do is we want this to be, the A is the starting amount, that's 1,500 people. We're going to get that when the exponent is 0. But first, the B, if it's increasing by 2.5% per year, that's going to be 1 plus 2.5% to the power t minus 2014. So when you plug in t equals 2014, the exponent here is going to be 0, and you're just going to get that 1,500. If you plug in t equals 2015, that's going to be 1 year later, and you're going to get the 2.5% increase. So I'm going to write this as p equals 1,500 times 1.025 to the power t minus 2014 there. Now in the year 2023, or 2023, I guess you'd say, this is going to be (1.025) to the power 2023 minus 2014. That's going to make that exponent be 7 years later. So, wait, no, 9 years later. So it's going to be 1,500 times 1.025 to the power 9. Is 1,873, and then a third of a person. So maybe somebody's giving birth at that time and the baby is 1/3 of the way out. Or maybe it's I don't know how you count it. So anyways, it's 1,873 people. All right, so that is this section. This was a pretty hard one. If you're understanding how this stuff works, now's the time to practice it. Good luck on the quiz. Remember, you can always come back to the video. If you need help with the quiz, you can also pop into office hours if you're not sure how to do one of the quiz questions, and I'll be happy to help you there. All right, good luck. Have a good day.